I'm adding it all up now.
Okay, maybe I'll just start talking about it. Maybe see if we agree. So, see, this is 27, right?
Yeah,
And you know this is 3, right?
yeah,
You already had this, and this is 9.
yeah,
Okay, so that's 9. So your volume is going to be a multiple of 9, yeah?
yeah,
Which rules out this, and it rules out this only, yeah? Okay, now it says everything's a whole number, you see?
yeah,
So this is probably 7, though it could be something else. Let's try 7. So this was 7, right?
yeah,
Um, this would be 6. This would be 7. This would be 5. This would be 4. Then you get 9 times 10 times 10 times 9. Sorry, that's 9 times 10 times 6, yeah?
yeah.
Is that what you got?
Yeah,
Okay, I mean, this might not be 7, I guess. So, but it has to be a factor of 28 and 42. I guess it could be 14. If it was 14, that would be a 2. Oh, let me just do another color. This was 14. Um, this would be 3. This would be 10, which is bigger than 9, right? That's not allowed.
yeah,
Yeah, actually, if you find one that works, it has to be the right answer because it's meant to be unique. Um, so let's check that again. So you have 9, 7, 6, 5, 4. That all works out, yeah. 16 is B, yeah.
yeah,
Okay, while you you look at 17, yeah.
yeah.
I'm gonna switch screens for a sec because I want to write down 16. So can you? Oh, actually, no. I'll do it at the end. I'll just put it in the chat.
Okay,
We got 16B, do we? Or maybe you can type it in the chat when you get the next one, okay?
okay.
Okay. I think we can go for a bit longer as well.
I have
It's C.
I was drawing 3 numbers. Actually, it should be 4 numbers. So this is T is the largest. You think it's C?
Question 17, yeah.
Okay, so this question can be checked. If it's C, if it's the largest, the odd numbers have to be like that, right?
Yeah.
And then this is 2 times 7 minus 1. Which it is, yeah?
Yeah.
Okay, so can you type 17C?
7. So it's C.
Okay, let's do 18. Anything?
Not really.
Do you know how to figure out the area? Is the area of a triangle is half base times height, yeah?
Yeah.
Can you figure out the area of any of them?
No.
Okay, so remember the question says it's side length 10, remember?
Yeah.
So if it's side length 10, then this is 7, right?
Yeah.
This is 4. This is 10. This is 6, yeah?
Yeah.
Which means you have the base of all the triangles, yeah?
Yeah.
Did you need an in the height? Yeah?
Yeah.
So I guess like C and D, they have the same height, right?
Yeah.
So that means D is gonna be bigger than C, yeah?
Yeah.
So A and B have the same height, but A is like a trapezium, you know?
Yeah.
Actually, A and B have the same area because you have two triangles. So this is like a 3 and this is a 4, right? And that's a 7. That makes sense.
Yeah.
The area of B and A are both equal to 7 times 6 divided by 2, which is 21. And here, the area of D is 6 times 6 divided by 2, which is a little smaller, right?
Yeah.
So
it's not D.
it's probably E because you can't tie, right?
Yeah.
So if A and B
Yeah.
are tied, and E has probably got a bigger area. And E is a trapezium, but if you don't know how to do trapezium, you can just do two triangles. So, for example, this triangle here has base 10 and height 4, right?
Yeah.
Yeah.
And this triangle here has 4 and 4,
Yeah.
you know? Okay, so what is the area? So it's 4 times 4, which is 16 divided by 2, plus 4 times 10. Oh. Wait, the area of E should be huge. Why is it? What is the area of E? So the area of E is 10 plus 4 times 4 on 2, yeah?
Plus 2.
So it's 14 times 2. Whereas the other one is
It's 28.
6 times 7 on 2, yeah?
Yeah.
Which is equal to 3 times 7. So the question is 3 times 7 bigger or 14 times 2 bigger? 14 times 2.
3 times 7 equals to 21. And then 2 times 14 equals to 28. So 2 times 14 is bigger.
Okay, but you could also do this. So if you don't want to times it out, you can write this as 7 times 2 times 2, yeah? And so 2 times 2 is bigger than 3, yeah?
Yeah.
And so it looks like E is the biggest. What do you think?
Yeah. I think E is the biggest.
Do you agree, Aiden?
Yeah.
Okay, so let's put that as E in the chat. And do 19.
A, I'm pretty sure.
Okay, so this is like a standard algebra question, you know? So if you let the number of cars they have be like S, R, and T, right?
Yeah,
Then you know S plus R plus T equals 300.
yeah,
And you know that gives them away to Sandy. So R plus S equals 180, right?
yeah,
And if she gives them to T, so R plus T equals 200,
yeah,
you know? So this should be pretty, you could do a lot of things here. So you could think of this as R plus S here is 180. So then this is 180 plus T equals 300. Which makes T equals 120, right?
yeah,
And if T is 120, then R plus 120 is 200, so R is 80, yeah?
yeah.
Is that what you did?
It's a bit different. I think
Okay.
my way was way slower. I think it was just luck because I was gonna do like process of elimination. So
Okay, but once you know it's 80, you can just try it, right? So
yeah,
180, 120 plus R equals 200, then R equals 80, yeah?
yeah,
But once you know R is 80, you could just go straight to the question here and be like S is 100 and T is 120. So 100 plus 120 plus 80 is 300, right?
yeah.
Okay, so maybe you can type that in the chat. 19A. 19A. Okay, once we get to 20, I'll start typing them into the website. Let's do 20 first. Hey,
Baba.
do you understand the question? Hello? So
Oh, my
there?
mic was on mute. My mic was on mute, my bad. I think it's D.
Okay, so you understand the question, right?
I'm pretty sure, yeah.
So you basically just have a square that's the face of the dice is on, right?
Yeah.
And then it rolls so that 4 is on the bottom,
Yeah.
and then it rolls again so 5 is on the bottom, yeah?
Yeah.
And then it rolls again so that whatever was on the bottom here, opposite the 1 is on the bottom, yeah? What? Alright, so when it flips,
I think we
so it
only
goes
need to
4, 5. So on the first square, it has 4 on the bottom with
Oh
5.
wait. I thought the cube was floating. I
It's
didn't
just
realize it was on that grid.
flipping, yeah.
Yeah.
So when it gets there, it'll look like 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 that. The first flip has the 4 down the bottom, the 3 is at the top. The 1 is facing outwards, and the 5 is next to the 1, yeah. And then when it flips again, the 5 goes down the bottom, yeah.
Yeah.
The 1 stays on the outside. So it's a 1 with a 5 down the bottom, which means there's a 2 at the top. And it's a 3 showing that way. And then it flips again. It'll get the 1 at the top. The 3 on the side still. And the 5 will now be here, right? And then it finally flips one more time, does it? Okay, so then it does it one more time. 3
It should
should
be
be on top.
3, right? Yeah.
That's interesting. Okay, so C.
Yeah.
Okay. Hmm. Do you have the file with you as well?
Um uh
It should be in your downloads.
yeah.
When we look at 21, I'm gonna just put these up on the
Yeah,
left.
it's already in my downloads.
Alright, so let me just let's see, A20C. So BCEAC. BCEAC. Alright, welcome 21. I might post this up. Let's see. What's just this? Oh, what was 15? It was 6, right? I think it was 6. T. PCAC. Alright, back to it. It's pretty funny. Little Michael looked at like one question and then fell asleep.
I don't understand the question.
Let's see. Leonard is designing a puzzle for Katerina. It has 9 squares and a number of clues. Each clue is a number 1, 2, or 3 placed in one of the squares. Katarina then has to find a solution by placing 1, 2, or 3 in each of the remaining squares, so that no row or column has a repeated number. What is the smallest number of clues that Leonard could include so that his puzzle has exactly one solution? I guess it's confusing because it uses the word clues to mean something kind of not obviously what a clue means, and it's specific. So, for example, maybe instead of calling them clues, it's just Leonard writes a certain number of numbers in the grids.
Okay.
You know? And basically, I think if you have basically Katarina's job is to complete the grid without writing repeated numbers in rows or columns. Just writing only the numbers 1, 2, and 3.
Okay.
Okay, and then Leonard can start her off by writing numbers in squares for her, you know?
Yeah.
And so obviously if Leonard just writes all the squares and Katarina doesn't do anything, then it's finished, right?
Yeah.
So the number is smaller than 9, right? Or if Katarina, if Leonard writes if he writes all of these numbers except for 1, yeah?
Yeah.
Then Katarina has no choice but to put 1 there, yeah?
Yeah.
Because it has to be different than these two numbers, yeah?
Yeah.
So the question is, like, how many numbers does Leonard can Leonard fill in so that the rest of the squares are determined, yeah?
Okay.
If that makes sense.
Yeah.
Just do some random numbers here. Like if you do 1, 2, 3. If that's what Leonard does, then you're forced to put a 1 here, right?
Yeah.
2 here, 3 here, 3 here, 1 here, and 2 here. Okay.
I think the answer is 2. Oh wait, never mind. Actually,
The answer is 2.
uh, you diagonals don't count. So.
Wait, did you rule out 1?
Huh?
Have you already ruled out 1?
Yeah.
Yeah, so I guess if it was 1, like you can just swap the 2 and the 3, right?
Yeah.
As long as there is a solution, you can just swap the 2 and the 3. We know it can't be 4 or 5, yeah?
Yeah.
So basically the question is, can it be 2, yeah?
Yeah.
Okay. Hmm. Any progress?
I'm just testing different ones out.
Okay, good. Yeah. Mm. Which ones have you tried?
Wait, what do you mean?
Have you found anything with 2?
No.
Have you tried this? Putting a 1 and a 2 here.
Yeah.
What did you get?
Hold up, let me put this. I got 1, 3, 2. So like,
Like that, yeah?
yeah. And then at the bottom row, 2, 1, 3,
Mm-hmm.
and then 1.
Oh, so you already got this.
Yeah.
Can you see that that is what you need?
Um, there are different ways to do it though.
I didn't think so. What do you mean?
Like, there's another solution.
Oh, so you say it's the 3 is not forced or something?
Um,
Like the blue numbers, are you saying any of those could be different than what they are?
oh yeah.
Hmm.
Oh wait.
But can you see like the 3 has to go here, can you see? Has to be a 3 there.
Oh yeah.
So it has to be a 2 there, and by symmetry, these have to be 3 and 2 as well. Yeah.
Yeah.
So that's the only solution, right? Because once you have
Yeah.
two things in a row or column, you know the third thing, and just gotta check that that works. So for that question, I think there's some kind of symmetry with rows and columns. You might be able to what's called log that So like if you put one number in the squares, you can basically assume that that number is the top left corner, you know,
Yeah.
and that it's a 1, you know.
Yeah.
And then there's sort of three cases. The second number could be on the same row, the same column, or a different row and a different column. So the same row, same column is symmetric. So like if it was here, it's the same as you put the 2 there, right?
Yeah.
And if you put a different row, different column, I think it's still pretty much equivalent to putting it here. There's really only two cases. And then I guess luckily this actually gives you the answer, so the log doesn't need to check out. You don't have to be super careful about that working.
Yeah.
Okay. Maybe, so we're approaching the 75-minute mark. How about we read question 22 and then maybe you can solve it during the day tomorrow.
Okay.
And then I'll meet you again. See where you're at, yeah?
Okay.
Alright. Good stuff. Have a good night.
You too. Bye.
Bye.